recall that our most basic linear function is what we call the linear parent function. And we know that those equations are written as y equals mx plus b, but the parent function has a slope of 1, so it's just y equals x or 1x, and your plus b is 0, so you don't have to put a plus b. So this is the linear parent function. Okay? Similarly, our most basic quadratic equation is called the quadratic parent function. So basically, same idea, right? It hasn't been shifted up or down. It's not made any wider or more narrow. So we know that all quadratics have an x squared in it, right? That's what makes it that U shape. So the equation here is just y equals x squared. So your parent function has no extra numbers, no plus or minus some numbers at the end, just y equals x squared. All right, so in this first example, it says they want us to make a table and graph the quadratic function of y equals x squared. So I could do that one of two ways. I could just pick some numbers and plug them in, or I could just go into my graphing calculator, go to y equals, and just put in y1, y is equal to x squared. Okay? If I put that in, all I have to do, my window's probably, yeah, I can change my window so we can see it a little bit better. All I have to do is hit graph though, and then I should be able to get an idea of what this function looks like. And then if you notice on the example itself, it wants us to fill in the table. So basically fill in some values for what this would look like. Okay, give us some coordinate points. Well, we can see it makes that U shape, right? I'm going to press second graph and pull up my table. Okay, obviously if we're supposed to be graphing the points, we don't want them to be too small or too big because they won't fit on that little graph there, right? So mine is shifted way down, but when you pull up your table, it should still be around 0, maybe a couple places above or a couple places below. Oh, I'm going too far, aren't I? Wrong direction. Uh-oh, she's gonna freeze. Okay, well, we'll just ignore that for now. If I was to pick some values, I want to pick small numbers, right, so that they fit on my graph. So let's say I pick -3 for x. Well, on that table, what is y when x is -3?
-9.
Good. Not -9, but +9. Okay?
You can do
All right, and then let's say I look at -2. If I put -2 in the x column, what do we have for y?
4.
Right? What about -1?
1.
Good. What about 0?
0.
Good. What about +1? What about +2?
4.
And +3? Very good. Okay, so I just pulled those from the table in our calculator. I'm going to go over here and plot those points so that we can draw our sketch. So my first point is at -3, 9. So I count over -3, up 9. My next point is at -2, 4. My next point is at -1, 1. I have a point at 0, 0. And then I have the same points just on the other side, right? +1, 1. +2, 4. And +3, 9. Once I have those points plotted, I'm just going to connect them to make that U-shaped parabola that we are familiar with. Okay? All right, so for this specific graph, where is our vertex at? What coordinate point? Very good. So our vertex is at 0, 0. Where does that mean our axis of symmetry is? X equals 0. Nice. Okay. How many x-intercepts do I have here? 1. Just one X-intercept. It only touches the x-axis in one place. Where at? Okay, so for my x-intercept, I'm at 0, 0. They said they want both of the intercepts here. So my other would be the y. Well, how many times does this touch the y-axis? Once. Where at? Also at 0. Good. So my y-intercept also at 0, 0. Okay, my domain, what should it be? Very good. It's never going to stop going left or right, so all real numbers. My range. Does this thing go up forever? Yes, but does it go down forever? What's the lowest it goes? 0. So how would I write my range? Right, so 0 or bigger, so y is greater than or equal to 0. Nice. Okay, so like we said, this is the most basic quadratic, right? This is what we call the parent function. Okay, now we're going to talk about if we change any parameters, what that would do to our graph exactly. Okay, so it says we're going to graph these functions in our calculator. Okay, so on number 2, it says what I'm going to put in y1, y2, and y3. So I'm going to go in my graphing calculator. Okay, go to y equals. Okay, in y1, I'm just going to leave it as x squared. In y2, I'm going to change it to 2x squared. And in y3, I'm going to put in 5x squared. Okay, everybody got those typed in? Okay, and if you'll look up here, mine is going to graph each one in a different color, so it makes it easier to tell them apart. You can see the first one they're going to do in blue, the second will be in red, and the third one should be in black. Okay? Alright, so watch me hit graph. Okay, so there's the blue one. There's the red one, the second one. And then, any day now? There it is. There's the black one, the third one. So what happened to each one of these? Right, it got skinnier, right? It was smushed in, right? Okay, so it says, how did this affect the change of our graph? He said it got thinner or it got more narrow. So we would say the parabola gets narrower. Okay. This will often be referred to as the graph being stretched. So you may want to put that in parentheses here. It stretches. So if they tell you that your function stretches, this is what they're referring to. Okay, so what was happening to the numbers in the equation as these got skinnier? What happened to the number in front each time? Right. So the bigger the number in front, apparently the skinnier or the narrower it's going to make it. Right? Okay. Same idea here on number 3. They want us to go back into our graphing calculator and change our functions to these. So y1 is still just x squared. In y2, you're going to put in 1/2 x squared. So alpha y equals, enter, 1/2, arrow over, x squared. Okay, and in y3, we're going to put in 1/5. So we got 1 over 5 x squared. Okay, now I'm going to hit graph. Okay, so there's the regular x squared in blue. There's the 1/2 in red. And then lastly, there's the 1/5 in the black. So what happened to our graph this time? Got wider. Very good. So that's what I'm going to say over here. How did that change our graph? The parabola gets wider. Okay, This is often referred to as the graph being compressed. So if they tell you the graph has been compressed, it's basically like something was on top of it and smushed it down, made it wider. Okay? So this is the same thing as compress. Which phone up, please. All right. Okay. On number 4, this time they only have 2 different graphs for us to type in. So I go back to my graphing calculator. In y1, leave it as the x squared. In y2, I'm going to put in negative x squared, and then just clear out your y3. Nothing to put in there. All right, so I graph those. My x squared is there in blue, and my negative x squared is in red. So what's the difference between these two? Right, flips it upside down. Very good. So what does this do to our graph? We're going to say the parabola flips so that now it opens down, right? So normally it opens up like this. What that did is flip it down so that it opens in the downward direction. Okay? This is often referred to as reflecting across the x-axis. So if somebody tells you that your graph has been reflected across the x-axis, this is what they did. They just flipped it over. So reflected across x-axis. Okay? All right, and then we got one more. This last one has us changing our y2 and y3 numbers at the end of the equation. So in y1, I leave it the same. In y2, I should have x squared plus 5. And in y3, put in x squared minus 5. I hit graph. The one in blue is my regular x squared. The one in red is my x squared plus 5. And the one in black is my x squared minus 5. So what happened to those graphs? Moves it up and down. The plus 5 moved it where? Up. And the minus 5 moved it down. Very good. Okay. So, how did this change it? Adding 2x squared shifts it up. And subtracting from x squared moves it down. So basically, in these 4 boxes, what we've said here is if the number in front of x squared gets bigger, that makes our graph narrower or skinnier. If the number in front of x squared gets smaller, like a half or a fifth, it makes it wider. If we put a negative in front, it's going to flip it upside down. And if we put a number on the end, that's going to move it up or down, depending on the number, right? Okay, so flip it over onto the next page, and they want us to put that into words here. So it says if a is greater than 1, so a from this equation is the number in front of x squared. What happened? What happened when our number was 2 or 5 in front? Right. And we said that that's called stretching, right? So it stretches vertically. Okay, what about if that number in front was between 0 and 1, like a fraction or decimal? What happened? Right, it got wider, which we said we call compressing. So it compresses vertically. Okay? What about when a was less than 0? So less than 0 means negatives, right? When we had a negative in front, what happened? Reflects. Very good. Okay? And then lastly, D is the letter here at the end. It says if that number was greater than 0, so a positive number, what happened? Good. Shifted up. And if that number was less than 0 or negative, what happens? Very good. All right. So now, no matter what the numbers actually are, because of these rules, we can predict what the graph should look like because we know how it changes it. Okay? All right. So it says they want us to match each one of these graphs with the correct picture and then fill in its domain and range. Okay, so on number 6, we've got a 2 in front of the x squared. What should that 2 be doing? Stretch, right? So it should be skinny, right? Is it going to be moved up or down any? No. Is it going to be upside down? No. So I'm looking for a graph that looks skinnier and still starts at 0, 0. Very good. Okay? In picture C, what is my domain? All reals. Very good. My range, does this thing go up forever? Yes, but does it go down forever? What's the lowest it goes? Very good. So y has to be greater than or equal to 0. All right, on number 7, we have a negative in front of the x squared. What's the negative going to do? Flip it upside down. So we're looking for a negative 1, and it has a plus 2. All right, so it does have to be D because instead of starting at 0, 0, it was moved up 2, and it's upside down. Okay, so what is my domain? Always all real numbers. What about my range? Does this thing go up forever this time? Right, it's going to go down. So the highest it goes is 2. So like we said, that means y is less than or equal to 2. All right. Number 8, we're looking for x squared minus 2. What does that mean is going to happen? Down 2. So which one of these starts at down 2? Very good. All right, what's my range for B? Nice. Negative 2 or bigger. All right, so what does that mean? Number 9 is going to have to be A, right? Which makes sense because what should 1/2 do to the picture? Right, make it wider or compress, and that one is wider. Okay, and what's my range for A? Right. Y is greater than or equal to 0. The way we check to see if it's skinnier or wider than what it should be is you check 1, 1. So check 1, 1. Okay? If it hasn't been stretched, then it should have a point at 1, 1. So here's my vertex. If I go up 1 and over 1, we have a point there, right? So that one has not been stretched. If I look at A, and I go from my vertex up 1, over 1, is there a point right there? No. So that's how I know if it's been stretched or shrunk. Okay? Same thing here. Here's my vertex. If I go up 1, over 1, there's not a point right there. So I know that it's skinnier than it's supposed to be. Okay? All right. Last page. Okay. Number 10 says that the graphs of f of x and g of x are shown. If f of x is x squared minus 7, what is the equation for g of x? Well, what's the difference between f of x and g of x? What? Okay, well, they're pictures.
One's up, one's down.
Right, one's up, one's down. Okay, so they said that f is at negative 7. They want to know where is g? At positive 2. So if this is the equation for f of x, what should the equation for g of x be? Very good. Okay, so they ask, how does this compare to the graph for f of x? So what's the difference from f of x and g of x? How much of a difference is there?
Eight.
9, right?
9.
The difference between 2 and -7 is 9. Right? If you count the spots from here to here, there should be 9 units in between them. So I could say that f of x is 9 units below g of x. Alright. Okay, number 11 says that x squared plus 3 is going to be shifted down 6 units. What would be its new equation? Okay, so right now it's at 3. If I go down 6 places, where did you say that would put us, Helen? Very good. 3, if I go down 6, that means -6, would put us at -3. So the new equation, I'll call it g of x, would be x squared minus 3. Alright. Number 12, how does the graph of 2x squared plus 4 compare to 2x squared minus 1? So what's the difference between those two? Right. How many units? 5. So which one's higher? The 4 or the -1 is higher? The 4. So I need to either say this one is 5 units below the 4, right? Or that 4 is 5 units above -1. So which one of these answer choices says that? There you go. Alright. Last one. Says to start with the graph y equals x squared and then write each of these changes. Okay, so it says it vertically compresses. So what makes it compress? The fraction. So what fraction do you guys want to put in front? Okay. So I should have y equals 1/5 x squared. Okay? The next one, they want to show that it vertically stretches. What makes it stretch? A big number in front. So what number do you guys want to use? Okay? So I got y equals 4x squared. Okay? Then it wants us to translate it up. What makes it move up and down? A number at the end. So I'll have y equals x squared. What number do you guys want to put?
3.
Okay. So plus 3. And then last one, they want us to write an equation that shows it's going to translate down.
Down.
So what number? Huh? Okay. Y is equal to x squared minus. All right.